All right, so for today's review, this is going to be for tomorrow's quiz number 14. Um, we're going to start off with some basic things, right? So what do you call a polynomial that has one term, two terms, and three terms? And I'm going to kind of just get into this because you guys have had time to write this down. One term, we call it a monomial, okay? So all of these are called nomials, but it's just how many terms. So mono meaning one, right? So monomial, that's one term. If it's two terms, they call it binomial, because bi means two. And for three terms, it's a trinomial. Okay? There are going to be questions like this. By the way, your test is on quizzes, so make sure you guys bring a computer tomorrow. Okay? It's going to be on quizzes. So it's going to be multiple choice. Okay? At least I saw most of it was multiple choice. I don't think anything was fill in the blank. So you are going to have to just pick like how many, what do you call it if it has two terms? It'll say monomial, binomial, trinomial, quadrinomial. Just pick binomial if it's two, right? And move on. So that's pretty easy. Okay. Let me give you a little bit of time to do this. Number 2 says, what do you call a polynomial with a degree of 4, 1, 5, 2, or 3? So meaning the highest power is a power of 4, a power of 1, a power of 5, a power of 2, or a power of 3. That's the highest power on that expression. And so what do you call a polynomial with a degree of 4, a degree of 1, a degree of 5, degree of 2, degree of 3? Remember, the word degree means the highest power. Okay? So you look at your equation, and part A means that the highest power you see is a 4. So does anybody remember what to call a highest degree of 4? A quartic, right? That's called a quartic. So quartic. What about a highest degree of 1? This would be linear. Highest degree of 5? Quintic. Thank you. Yeah, quintic. How about 2? Quadratic. And then cubic, which you said would be the 3, right? Cubic. Okay? So there are going to be questions like this where they're just going to ask you, hey, the degree is this. What is it? Is it a quartic, quintic, right? They might give you an equation and you're going to have to look for its highest power, but just make sure you know those names, right? Linear is power of 1, quadratic is power of 2, cubic is 3, quartic is 4, quintic is 5. So again, nothing too hard about this. You just got to know definitions, right? That's what I was telling you guys when we were doing these lessons. I said your notes are the most important part of your assignment because that's going to guide you for your answers, right? So please make sure you guys look at those notes. Then we do get into some problems where we do have to solve some stuff, okay? So what are the roots of these polynomials? So there's an A and a B. I kind of have part B a little bit later because this does require a little bit of work. But remember, when you have to find roots, or what was another name for roots? The most common one? Starts with the letter Z? Yeah, zeros, right? So there are some problems on quizzes that they say the word roots. Then there's some where they're going to say, what are the zeros? So just remember, roots, zeros, solutions, answers, they're identical, okay? It means the same exact thing. So if you see roots, if you want to just say, no, I'm going to write zeros instead so I know what they're talking about, feel free to do that. You don't have to use the word roots, just think zeros, okay? So what you're supposed to do, if you remember the notes that I gave you guys for this, is they're going to give you a pre-factored equation. So there it is, pre-factored. And you're going to basically get each piece and set it equal to 0, right? So just to kind of write it out in the correct steps, first step is to basically give yourself your assignment, which is this right here. This is what I'm going to solve. And then I'm going to set each piece equal to 0. So 3x equals 0, x minus 4 equals 0, and x plus 7 equals 0. And remember what I told you guys yesterday, ignore the powers. I know x minus 4 has a power of 2. Just ignore it in order to solve it. You do want to pay attention to it when it comes down to the multiplicity of it, but you don't need to do anything for it when you're solving. Okay, so let's go ahead and solve each one. If I solve 3x equal to 0, what do I get? 0, right? So x is 0. If I solve x minus 4 equal to 0, what do I get? It's a 4. What about for the last one? -7. So I have 3 different answers. But some of these may have multiplicities, right? So I'm going to look at x equal to 0. I notice x equal to 0 comes from 3x equal to 0. 3x equal to 0 comes from the top portion, right? The 3x. What's the power on it? 1. It's a 1. And do we mention multiplicity of 1s? No. So all I'm going to write is the following. I know I'm writing this out of order, but that's okay. I'm just going to go from left to right. The next one I'll go in order. I mean, it doesn't matter. My next answer is a 4. I got the answer of 4 from x minus 4. And x minus 4 has a power of 2. So I'm going to say multiplicity 2. And then my last answer is a -7. I got -7 from the x plus 7. And if I look up, the x plus 7 has a power of 1. So I don't write that down. So I'm done. These are my solutions. Anybody have questions on this one? Like, I honestly think these were like the hardest questions to do. In the last 2 assignments that we did, these were probably the toughest ones because they had the most work. Most of the other ones were just kind of like identifying pieces, right? So it didn't take too long. To memorize multiplicity, I mean, to me, multiplicity has always been based on powers. So I would always say when you solve it, that's what you're talking about, right? When multiplicity. I would say when you're solving each one of these things, just like what I do is I always highlight powers. So you notice I do that even here because I know I'm supposed to take that into account. So like, for example, this one right here, if I'm doing this problem, the very first thing I do personally is I highlight powers immediately. Whoops, I wanted to change that color. I highlight them immediately because that right away tells me, hey, those have multiplicities, right? If it's a picture, then I have to look for bouncing and going through, right? Bouncing is even, going through is odd. Like I said, it's kind of hard to give you a little trick as to how to memorize them because I honestly have given you the easiest way to do it in your notes. There's an actual definition that goes through a whole paragraph of describing how to do the work, but I'm pretty sure you guys don't want to memorize a whole paragraph, so I paraphrased it, right? So I've given you like probably the easiest way to do it. It's just kind of practicing by doing, right? That's the thing about math is the best way to learn it is to do it, right? Non-related example, but you know, my dad was a mechanic for many years. He did other stuff as well. He worked in a restaurant as a bartender, but also was a mechanic for many years. He would do it on like as a side job because he just liked doing it. And when I got my first car for some reason, the Nissan Sentra 92 year, it was in 1992. For some reason, the alternators always went bad on that car. I don't know why. They just would go bad. So every 3 years, pretty much like on the clock, the alternator would start to go bad. That's what keeps your battery alive. That way your car keeps running. First time I replaced it, took me about 3 hours. Okay, he helped me, but he made me do everything. Second time I replaced it, he came in, helped me again. Took me about an hour and a half. By the 6th or 7th time, because I had the car for about 22 years, so I replaced it about 7 times, I was doing it by myself, and it would take me about 25 minutes, right? Took me about 3 hours the first time, 25 minutes the last time, because I was so used to doing it because I had enough practice that it was easy, right? I did all the stretching of the cabling on my own, didn't need people to help me do that. I figured out ways to do it, right? Practice, right? Practice. So, I mean, that's the only thing I can tell you. Math takes practice. Again, it's one of the reasons why mathematics and sciences are some of the most hated topics in high school and even colleges because it requires dedication and work and time, right? You know, so yeah, same with practicing basketball, right? Kobe Bryant didn't just wake up and shoot free throws. The guy used to work, after games for 2 hours shooting them, right? After the games. That's why he was so good at it, right? He could probably close his eyes. I don't know. Look up this video of Michael Jordan. He was getting heckled by players. Okay, look up a video on YouTube. Michael Jordan shooting free throws during a game with his eyes closed. All right? He would just do it, close his eyes, and shoot it, and he'd make it. And just look at the guy who was heckling him and smile. That's how much practice the guy had. His arms knew what to do. He didn't have to look. They already knew, right? So, yeah, practicing. I mean, unfortunately, that is the only way to get good at math. You got to practice it. The definitions, though, that I gave you, like I said, they probably are as easy as I can make them. So, I mean, you can simplify them more if you want in your own way, but I tried to make them as short as possible because I hate when definitions are long. It just gets more complicated. So, yeah, I mean, I don't know. Just practice it. Part B, again, highlight the powers when you're solving for zeros because multiplicity is there. Any powers, you want to highlight them. So that's one thing I would tell you for sure. And then rewrite your problem. So just set it equal to 0. You don't have to do this part. This is just what's, I guess you could say, theoretically sound. Okay. But from there, just go into the writing out each answer, right? So doing this right here. Solving for both, so we get x equal to what? 1, and the other one? -2. So I'm going to write my two answers. This time I'll put them in order. Not that it matters, but, bless you. A lot of times in answer books, they always have them in order. Does this one have multiplicity, -2?
Yes.
Yeah, what's the multiplicity? 2, right? So just look at the power that it came from, right? -2 came from x plus 2. X plus 2 has a power of 2. So that's why it's multiplicity 2. My other answer is 1. Does this one have a multiplicity? What is it? 3, right? So there you go. These are very quick problems, but like I said, they probably are going to be the most work you'll do because you do have to solve. Okay? But they are pretty quick problems. All right, so moving on. It's going to take you longer to write this example out than it is to do the actual work. Let me give you a minute or so to do that. I'm going to pause the video. All right, so for number 4, when it says what's the maximum number of turns, or sometimes they say changes in direction, that can occur for these functions, it's based on your degree. Okay, it's degree minus 1. What's the degree of part A? 5, right? Not 2. A lot of times people look at the very first power and they assume that's the highest power. Be careful, look throughout. So my degree is 5 minus 1 is 4. You don't have to show the work, so don't worry. I'm just showing it just so that anybody who's not here, if they see a 4, they're at least going to know how we got it, right? It came from here. Okay? So 5 minus 1. All right, what about for part B? What's my answer? 6, right? Because my highest degree is 7. 7 minus 1, that's 6. So there you go. Very easy. There are questions like that on your test. So I expect everybody to get them right. They're not hard to do. All right, we got 2 more. Now these are probably going to be the ones that you might benefit from being able to use notes. I don't know if we'll be able to, but if you are able to, these might be beneficial. The one little trick that I can tell you is this. Okay, even though I already gave you like the simplest form of the definition, but this is one thing I always remember. Okay, that if your degree is even, both arms go in the same direction. So both up, both down. Okay, it just depends on whether it's positive or negative, right? So for me, anytime I see an even degree, I'm thinking up, up, or down, down. Okay, if I see an odd degree, that's when they're different, right? It's down, up, or it's up, down. So that I kind of have to memorize based on what I see. Okay, but the even degrees are always easy for me because I always think, well, if they're even, they both do the same thing. So up, up, or down, down. Okay. Whereas for part B, it's an odd degree, so it's either going to go from the top to the bottom or from the bottom to the top. All right. So for part A, when we say describe the end behavior of that function, we can see that we have the degree of 6. So that's an even degree. Okay. So I'm going to kind of highlight it. So here's my degree. And then after you notice your degree is even, then you're supposed to look at the number in the front, which is positive. So what do we get if it's an even degree that's positive? Yeah, it's up, up, right? Up, up. So rises to the left, rises to the right. So that's your answer. On your quizzes, you're going to be allowed to pick 2 out of the 4 options, okay? One will probably say rises to the left, falls to the left, rises to the right, falls to the right. You just got to pick the 2 that are correct, okay? So rises to the left and rises to the right. And that's it. So same thing with part B. I'm going to highlight my highest degree, which happens to be a 3. And then I'm going to highlight the coefficient in the front, which is a negative. So if it's an odd degree, okay, with a negative coefficient, what does it do? To the left side, what does it do? Up or down? Up. To the left, it's up. And to the right, down. Okay? So it rises to the left and it falls to the right. Okay, rises to the left, falls to the right. Like I said, this is probably going to be like the hardest part. And if I'm right, there's like 4 of these. Okay? So really try to memorize that. Okay, I know it's not easy. It's 4 different things, and there's like 6 different situations in each and stuff. But I know it's not simple, but just give it some time, right? Don't try doing everything at once. If I can give you any advice, it's just like eating a cake, right? I guess some of you guys might actually eat it in one bite, but most people don't, right? When you get a slice of cake, you normally take pieces, right? When you're learning, memorizing definitions, take it a piece at a time, right? So start off with just the first part, even powers, right? Just remember, start with even and then say positive, negative. Just memorize those and quiz yourself over that. And then start doing the odd degrees, right? And then memorize those. And then start quizzing yourself over all of them at once, okay? Try not to do everything because then your brain gets overloaded, all right? People who love math, they can do it all at once because they just like it. They think it's interesting. But if you're not one of those like math fans, pieces at a time, okay? Piece at a time. If you can make a song, right? Because people memorize things with music very easily, right? How do I know that? How many of you guys know every word to a song you completely hate? Right? Like there's songs that you hate so much and you're like, I hate this song, and you know all the words to it. Why? Because you hate it so much that every time you hear it, your brain just keeps saying like, I don't like this song because that lyric is stupid, right? And you start thinking about it, all of a sudden you memorize it, right? Because there's a passion behind it. You don't like it, right? And you also memorize songs you really like, right? So the things that you don't really find too much importance in, you don't memorize that stuff. Yeah, I know a lot of Taylor Swift songs. Not because I'm a fan. My wife is, and that's all we listen to in the car. And I'm like, can we please change it to something else? She's like, no, but I'm a Kansas City Chiefs fan now. I need to, she's a fan of the Kansas City Chiefs now, brand new fan. I'm a Raider fan, so I'm like, I don't like you on Sundays anymore. So yeah, she likes her favorite player is Travis Kelce because Taylor Swift is dating him. Oh my gosh. And she wants me to get her a jersey. I'm like, nope. No, I'm not buying you Kansas City anything. Again, rivals, so I can't do that. So here we go. Describing the multiplicity of the zeros. I'm just giving you a picture here. Again, your picture doesn't have to match perfectly, but at least make sure that it's touching at -2, -1, 0, and at 2. Okay, so -2, -1, 0, and at 2. The ups and downs and stuff can be as high as you want, as low as you want. It's up to you. But just make sure it crosses through those x-intercepts. Because remember, zeros, we find them at the x-intercepts, right? So what are my solutions here? All right, negative, hold on, let me write this down. -2, -1, 0, and 2. All right. Now, what's the multiplicity on -2? Is it even or is it odd? -2 is odd. Why? It goes through, right? It goes through. Now, I don't want you to get confused with me saying what is -2 even or odd in terms of numbers, because yeah, -2 is an even number, right? But I need to know its behavior in terms of multiplicity, right? So if it goes through the graph at that point, it's odd. If it bounces, it's even. Okay, so what about -1? Is that even or odd? This is odd. Okay, what about 0? Is that even or odd? That's even because it bounced. You can see how it bounced right here, right? It kind of went and did a little curl, right? So it bounced off. And what about 2? Is that even or odd? Odd. And that's basically what your quiz is.